Hi guys, this is lesson 20, and this one's not too bad. If you've been doing decent with the mechanism videos, then this will be some kind of caveating off of that. So it's for the amine. I know he did like a shortcut, but I'm going to do the whole process because it helps me kind of understand what's going on. So I'm going to draw formaldehyde, so that's a carbon double bonded to an oxygen. And then ammonia, which is a nitrogen by itself, and add the hydrogens and hit arrange. And now I'm going to use the hydrolytic function to pass off some of the electrons to different molecules. So like we've been doing with the mechanisms, we want to get this oxygen to complete to be a water molecule. So that's the goal, and then to separate it, and then that would be our condensation products, but we're only going to want everything that's not water. So to do that, I'm going to take this bond and connect the hydrogen, and then I'm going to connect the nitrogen and carbon with the bond that was connected to hydrogen. Okay, and then I'll put arrange so I can see it better. Okay, and then I'm going to skip a step. Instead of connecting one of these to this hydrogen, I'm just going to take this bond and connect it to the hydrogen, and then release these electrons to the nitrogen and hit arrange. So I see I have my water molecule complete, and I'm going to go ahead and delete that since we're going to need that for the amines. Okay, and lastly, this is the step that I kept forgetting before, but we're going to need to complete this octet for the carbon. So I'm going to take this bond from nitrogen, connect it to carbon, hit arrange, and that should be the amine. So for me, I like doing the steps, just helps me see better and makes me feel like I'm actually kind of learning something. Okay, methyl ethanamine. I see the ethanamine, so I know it's going to be 2 carbons connected to a nitrogen. And a methyl at the end position, so on this nitrogen, I'm going to add a carbon. And then, see, I'm going to add my hydrogens, hit arrange. And I also have my notes. It kind of helps me out just to write down the different things and help me visualize everything. So I'm actually going to undo that and do a double bond between one of the carbons on the ethanol and then the nitrogen. Now I'm going to add my hydrogens and hit arrange. So this is the end product for N-methyl ethanamine. And let's see. Okay. This should be good. Okay, so condensation products to me are pretty fun, but I'm weird, I guess. So I'm gonna complete the water molecule by taking the hydrogens from nitrogen. So I'm gonna use hydrolytic, take this bond over here, connect it to the hydrogen, and I'm gonna use this bond to connect to the carbon. I do that because I'm trying to do as little moves as possible. Okay, and now I'm gonna take the bond that's connected from oxygen to carbon and connect to the hydrogen, and I'm going to release this, the electrons back to nitrogen. Okay, so I think I connected the wrong bond, but that's not a problem. I'll just go ahead, put this back on carbon, and connect the hydrogen. Arrange, and now I'm going to disconnect my water molecule, and I'm going to leave the water molecule because it's asking for all the products. And the last step is that I see this carbon doesn't have its full octet because it only has 3 bonds. So I'm going to take this lone pair, connect it to the carbon, and that should be good. we've got our water molecule, and then our main molecule here with the double bond. So those are pretty fun to do. I like them a lot, and they're not too bad. Okay, carbonyl amines just means that we're going to connect these two, and we're going to have an incomplete water molecule still connected to the carbon. So it kind of reminds me of like the third and fourth intermediate that we've been working on with the mechanisms. So I'm going to take this hydrogen right here and then connect the bond back to carbon and hit arrange. And I'm going to leave it like this. So an incomplete water molecule still connected to carbon, and this will also be the same for the geminal aminos and the hemiaminals. So these aren't too bad either. Just got to remember incomplete water molecule still connected for carbinol, geminal, and hemiaminal. Okay, Enamine. I'm going to draw my cyclohexanone. Okay, I see dimethylamine, so I know it's going to have a nitrogen. Oops. Nitrogen, and then it's dimethyl, so it's going to have two methyls attached. And I know there's going to be a double bond right here because of this En on enamine. So I'm going to bond this. Okay, so I'm going to see if this is right. And I'm going to check my notes just to make sure. Let's see. Yeah, it looks about right. Let me zoom out so you guys can see it. Okay, I have my double bond for the enamine, En, how we learned in lesson, I believe, 19, cyclohexanone, methylamine, 1 nitrogen, dimethyl, 2 carbons attached of methyls. Okay. Hemiaminal, like I was saying before, the carbonyl amine, geminal, and hemiaminal, those are all going to be the complete or the incomplete water molecule still attached to the carbon. So I'm going to take that hydrogen to make it an incomplete water molecule, and then attach this bond to carbon and hit arrange. And the reason that I don't do double bond here is because this carbon has 4 bonds already. So incomplete water molecule still attached. Not too bad. Condensation products, my favorite. Oh, it's a little zoomed in, so I'm going to resize it. Okay. So like we did before, I'm going to try to make a complete water molecule and then dissociate it from the compound. So I'm attaching a hydrogen, to which then I'm going to attach that bond from nitrogen to carbon. And then to skip a step, I'm going to take this bond from carbon and oxygen and attach this hydrogen. And I'm going to attach this. If you wanted to, you could just skip. You don't have to bring these electrons back. You can already just do the double bond. But just to show you guys, just to do that extra step, because okay, so we see our water molecule here and our incomplete carbon, and then we just take those lone pairs and create a double bond. We're going to leave everything on the canvas because it's the condensation products. Okay. Okay, we see geminal again. So we're going to do the incomplete water molecule attached to the carbon. So I'm going to take this hydrogen and bond the bond from the nitrogen from hydrogen to a nitrogen to carbon. Hit arrange. I have my incomplete water molecule still attached to carbon and my carbon with complete 4 bonds. So that should be it. These are just so easy. I like those a lot. I guess the harder ones would be amines, but that's not too bad. Okay, so we're going to draw an ethanol first. So 2 carbons and an oxygen. And then methyl amino, so that's going to be a nitrogen attached to a carbon, just one. That's at the 1 position. So I'm going to put it right here. Nitrogen. And carbon. Add my hydrogens and hit arrange. And we see there's an S, so there's going to be a chiral center. Okay, so the chiral centers have to be carbons, so this can't be it. This has 3 hydrogens, this has 3 hydrogens, this is an oxygen. And so we see right here the carbon has an OH group attached, methyl, and then right here the methyl amino. So that's our chiral center, and we can look at our periodic table to see which has the highest priority. I'm gonna look at mine. So oxygen has the highest priority. These are pretty easy because we're just comparing carbon, oxygen, and nitrogen. So oxygen has the highest priority, then nitrogen, then carbon. So R, I see it as we're going around right or clockwise. Right is R, but we need to be going around this way. So we're gonna mirror it. Mirror. And I'm gonna check the conformations again because I like to double check. We have our oxygen, our nitrogen, and our carbon going around counterclockwise. So that is the S. And I'm just gonna check my notebook and make sure I wrote it down correctly. It looks like it's good, so submit. So yeah, but as you name this structure, I guess that's the trickiest one because sometimes it's not so easy to see that chiral center, and you'll get the name right but forget to put the S or the R. I know I did that. Okay, now we're gonna name this. I believe we might have had this one earlier. No, we didn't. Okay. So this is actually a hydrazone. This is the hydrazone of cyclohexanone. So if it asks you to draw the hydrazone of cyclohexanone, this is what you'll be drawing. But just to name it, it'd be cyclohexane hydrazone. I don't believe there's any spaces. I hope not, but it can be classified. The hydrazone is 2 nitrogens attached to each other. So whenever you see hydrazone, you know there's going to be 2 nitrogens. And then double bonded to the carbon, cyclohexane hydrazone. Okay. And yeah, I believe that is it. Okay. Good luck.